Let's start today's class, okay? We have many topics to go through today because Columbus students is going to learn the parametric equation. The Dulles Academy students is going to learn the law of sine and the law of cosine. Now let's do the law of sine, law of cosine first. All the notes, the blank worksheet has already been uploaded. You can print it out. Let's talk about the law of sine first. You have a triangle, any kind of triangle. Doesn't matter it's an obtuse triangle or acute triangle or right triangle. The area is always using the base times height and divided by 2. So for ABC, you can do A times H and then divide by 2. And you can do B times this side altitude divided by 2. And you can also do C times this direction altitude divided by 2. And we also know the basic definition of sine cosine. So what do we have here? If we say A times H, for this H, we have what? We have sine B equals to H over C. So that means H equals to sine B times C. So you have lowercase c times sine uppercase B. Or you can also see the B times sine C. B is this hypotenuse times this sine angle. We'll get this altitude. So you have H equals to this. In that way, you can replace this H. So you have 1/2 A times B times sine C. You plug in this one here. So what you have? You have 1/2 A times C times sine B. And you can also replace this for your H, which you have 1/2 A times B times sine C. So you got this. And you might notice that you do A by C by sine B. And you do A by B and then by sine C. You can also use the H1. If you choose your base as C, then the area will be 1/2 C times H1. And H1 can be replaced by B times sine A. Or you can do A times sine B. So in that way, you can also figure out your area can be 1/2 B times C times sine A. After you have all these three equals, everybody times by 2. So you'll notice that any two sides product times sine of this angle between, that's going to be your area. And you have this, and you have this. When you have this, this is our law of sine. This law of sine is saying everybody you divide by A and B and C. Then you will see what happened. You have sine uppercase C over C equals sine A over lowercase a equals sine B over B. This is the famous law of sine. Okay? Go ahead, quickly write down the way we prove this law of sine. I want you to be able to prove it by yourself. And then we are going to use this law of sine to do the ambiguous question. That is kind of confusing. The name is confusing and the question is also confusing. So starting point is the law of sine, which is this. From here, we are going to do the ambiguous question. So let's talk about it here. If I give you two side lengths and I give you an angle, you might have different scenarios. So it might sound very confusing here. Let's first talk about some questions. So let's do some questions here. Number one, look at this. Let's draw this triangle. You have what? Look at this. They give you the two lengths and give you the angle, and they ask you to solve the triangle. Let's draw this triangle. So we can draw here, and your angle C is showing 90 degree. So the uppercase is for the angle. Then this lowercase c, we put 36, okay? And then the d, lowercase d is here, equals 22. And this is a big angle, which is angle D. Okay? And then what do you have? They ask you to solve how much is this angle. When we were given a triangle, if one angle is 90 degree, then all the other two will be acute. Because why? What do you think?
Because like it should all equal to 180.
Yes. The interior angle summation is 180. You couldn't have two angles like 90. That's not going to be a triangle. If you have one angle 90, then the other two summation can only be less than 90. Okay? So that means we don't worry about you might have two types of triangle, just one triangle. And what you do, you start to see here. This is just a basic sine definition. You have D, you will ask for D. So what you do, you are going to do sine D equals to who? Opposite over
22 over 36.
Yes. So you can use calculator, and you can definitely use a calculator, and then you can find out the sine inverse. Yeah. So you do sine inverse, and you do 22 over 36. Okay. And then you find out your angle D. Okay. Yeah. You do one more question here. Look at this. This one. This one, they didn't give us any obtuse or right triangle, right angle. So we have to draw this thing. They have AB, so we call angle A here, which is 44. And B here, which is 61 degree. And they told us this B equals to 61. Okay? And then we want to do what? We want to do
B
this,
equals.
oh, sorry. This is 70. I have a typo. So this is 70. Okay, let's try to do the law of sine. Go ahead, please. You want to get your A, what you do?
I do 44 degrees.
You do sine?
Yeah, well, yeah, sine 44 degrees over A equals sine 61 degrees.
Yes.
And then over B, which is 70.
Yes. And B is 70, so you put 70. And then you can solve this, okay? This one, you don't need to worry about. You might have two solutions of the triangle because you were given all the two angles. The third angle is just using 180 minus this, okay? So just one type of triangle can be formed because all the three angles are fixed. And then you find out angle C by using 180 minus that. And then you have the angle C, and you can solve your lowercase c, okay? Yeah. Now, this two doesn't have the two triangles. So in what scenario, you might have two different triangles. So let's talk about here. For this part, as long as you can understand this question well, you can handle this part, okay? Yeah. Columbus students, you don't have this the coming week, but you will have this question for sure very soon. Dualis Academy, you will have this quiz very soon, so be very careful for here. This question, they give you one angle, but they give you two sides. This one might be dangerous because this angle, if it's 90, or if it's more than 90, you don't worry because you only have one right angle or one obtuse angle. But this is acute. Then you may have several different scenarios. Let's call Daniel. Look at here. I'm going to redraw this one. For any given question, if they give you one angle and they give you that angle's opposite side, and they give you another side, and if this angle is less than 90 degrees, we have to be really careful. So Daniel, what I'm going to do, I'm going to draw an angle A first, okay? And this is going to be 49 degrees. I've specified here 49 degrees. Now, for this B, I'm going to make this on this next to A, because lowercase a to uppercase A, so the A, lowercase a will be here, but the A will be this, or here, or here, or here, or there. We don't know yet. So we know the B is this. So we write down this. For this ambiguous question, draw your angles of this acute angle first and draw the other side. Don't put 21.5 here. No, that's not right. Put another side. And where's your point B? It could be here, it could be here. You don't know. You will based on that guy to help you know. So you roughly say, now I'm going to check. I'm going to check the altitude from here to here. So let's see, this H is how much, okay? Daniel, that is hypotenuse. This is 49. How much is H?
23.9 sine 49 degrees.
Yes. So you do that. And you can use calculator. Everybody quickly do your calculator. See if this guy equals to 18.04. Everybody get the same answer? Okay. Now, this B equals to 23.9. We have to be really careful here. The 21.5 is higher than this one. What will happen if I tell you my A is 18? Daniel, if my A is 18, what will happen? You think your A are able to touch to this side? The shortest distance from this point to this side is this perpendicular line distance. Any other distance will be higher. So if this value is 18, you will not be able to form a triangle. You put this hammer here, but this point cannot touch this side. So if this number is less than that altitude, no triangle can be formed. 0, no triangle. But if this A is exactly this, and then you will see one triangle can be formed. You will form as a right triangle. Now, look at this. What kind of situation can you form two triangles? You have to satisfy number one. You want to be greater than this altitude. Your A want to be greater than this one. This is the first condition. Number 2, this A cannot be greater than or equal than this. Look at here. If I give my A as 23.9, which is same as that, you will form a isosceles triangle like this. Some people say, no, you can also go to the left. Oh, if you go to the left, then you overlap this side. This is a one line. You don't form a triangle. What will happen if this A is greater than 23.9? You'll say, oh, also two triangles. You make one longer side touch here. You make another guy touch here. Well, you try here. Then your angle of A is no longer 49 anymore. It's going to be 180 minus 49. So if A is greater than this value or equal to this value, you only have one triangle going this side. If they are equal, you have this isosceles triangle. If it's greater, then you go beyond. You have this. So you have to see here this list. Number 1, if this value is equal, if less than the altitude, no triangle can be formed. If this A value, is equals to this, okay? Yeah. See here, let me change this. If first A is less than B times sine B, I need to change according to this letter. If A is less than B times sine A, no triangle can be formed. If A is equals to B times sine A, then you form this right triangle. But if your A value, if this A value is greater than B times sine A, but less than the B value, then you will be able to form the two triangles. Scenario 4, if this A value is greater than or equal than B, then one triangle can be formed on that side. If you do that side, you change your A angle. This is the full scenario. Now, for this, it satisfies scenario 3. So you have two triangles to be formed. And you may still feel confused. What do you mean two triangles can be formed? You have sine A over A equals to sine B over B. You plug in A as 49, lowercase a as 21.5. Sine B, you don't know, you leave it. And you have your lowercase b as 23.9. You have that equation and you solve this one. Because you do cross multiplication, you can solve your sine B. After you solve your sine B, you do the sine inverse to get your angle B. Okay? Sine B positive, quadrant 1, quadrant 2 are both positive for sine. So you get your B here and B here. Go ahead on. Now do your own calculation to figure out from this cross multiplication, you are able to solve your sine B. Based your sine B value, you can solve your angle B. But one is obtuse, one is acute. You find out your B, based on your B and A value, you find out your angle C. And then you can find all your side lengths and find all your angle. Solve these two different scenarios on your paper. Send me your work when you finish. If anyone say I still need help, unmute yourself. Okay, I will walk through with you. Class start. Okay, you have to give me the two scenarios, okay? So watch out here. If this side, you were given a acute angle and you were given this value. For this length, you don't know how many scenarios you have. You try this. This is the altitude. If your A opposite side, which is lowercase a, if that's less than this altitude, so you try to make this guy and you try to rotate this around to touch this side to form a triangle. But whatever you do, it's too short. You are not able to touch this side at all. So you don't have a triangle can be formed. But if you are exactly equals to this altitude, then you touch here, then you have just one right triangle can be formed. But if the given length is greater than this, but less than this, so you could have here, you could have this. With this length between the altitude and that side, you will be able to touch here. You will be able to touch here. So you can form two triangles. One triangle is this. One triangle is this. That's what's going on for the two triangles to be formed. For A angle 49 degree, lowercase a 21.5, you plug in. For the B, which is 23.9, and you solve your sine B. You do your cross multiplication, you find your sine B value. You do your sine inverse. Your B could be either 53, around 57 degree, or you can round to be 123 degree. Because all students take class, quadrant 1, quadrant 2, sine are all positive. So you solve your angle. You solve your angle B. This time, this is 57 degree. This is about 123 degree. You find your B. You have your A available. Then you use 180 minus this 2. You find your angle C. After you have your angle C, you use the law of sine. Sine B over B. Sine A over A equals to sine C over C. You have your angle C, you put it here over lowercase c. You solve your lowercase c. And same thing from here. You have B choosing that acute angle. You have your A already available. You use 180 minus this 2. You got your angle C. Then you plug in, you solve your lowercase c. So this is a scenario corresponding to this, which is obtuse angle, triangle. But this one here is corresponding to this scenario, which is a acute triangle. And if you move this side, if you move here, let me make the length exactly the same. So what you do here, see here, you make that equals. Okay, so now you see I on purpose make this equal. So the scenario for the right is this. The angle A here is 49 degrees. And this angle B here, which is 57.03 degrees. And angle C here is around 27.38. I didn't draw this very nice. Let me adjust this a little bit. Okay. Okay, anyway, you know the geometry. Okay, you cannot suppose this is you solved by based on the number. Okay, so that's triangle here, and this is triangle here. And what you have A here, which is 49 degree, and you have the B angle here, which is 122.97 degree, and this angle B here, angle C here, is 8.03 degree. So you have these two triangle formed. Okay. You have given two sides, one angle. Then you have to be really carefully because this might be two different scenarios, or no solutions, or one solutions based on their length. Okay, you have to compare them to give the correct conclusions. Now, let's come back to this. We have a lot of things to go through today. Okay, we have some students send me their work. Let me check. Very good. Audrey Jean, yes. No, not Audrey Jean, Claire Jean. Yes, very good. Who else finished your work? Send me, please. You need to give me two scenarios, not just one. Thank you, Ethan. Who else finished? Now let's go back to here. When your school teach this part, you really have to be very careful. You need to be very clear about this. See here? This is my notes to describe this. So you don't just look. The way we learn this is not by just memorizing A and B and C and sign. You remember, you understand, because look, the angle number changed. This is A, this is B, this is C. If you just by remember this, you messed up. So you want to truly understand. If you were given an angle here, and you were given this length, so you use this length times this angle sine, you find out this altitude. And you were given that this B is opposite length. You compare this guy with this. If it's equal, you have one right triangle formed. If it's less than, you don't form any triangles. If you are greater than C or equal than C, then you have this side one triangle only, like that. If you are between this height and that length, you are able to form two triangles. The angle on this side is an obtuse one. The triangle on this side is an acute triangle. That's why when we learn triangle congruency, look at this. Long time ago in geometry, we learned triangle congruency. We have SAS, SSS, we have ASA, we have AAS. If you are given two angles, you don't need to worry about the scenario at all. You were given two angles. The third angle is fixed. You won't be able to have another different scenario of triangle. Two angles, one side, you already fixed your triangle already. But SSA, the reason in geometry, SSA cannot be used to prove two triangles to be congruent is because right here, during geometry, if you learn geometry with me, people always want to use SSA, but no, you cannot, because you have this side equal, which is S. And then you will see the next side equal. And then you have an angle. But the angle is not between these two. The angle is on one side. You have this equal, you have that equal, you have that equal. Is this two triangle congruent? Not at all. This guy and that guy is not congruent. How can you say these two are congruent? SSA is not a valid congruency theorem because of this thing. Two different triangles can be formed when your length is between the altitude and that. You have this, you have that. You have that triangle, you have that triangle. This is obtuse, this is acute. This is called a side angle. It's not congruent at all. That's why you have to be very careful. Now, I want everybody to truly understand this. Now, keep going on. Law of cosine. I may say, oh my gosh, you do too fast. Look, if you want to be able to survive in these two high schools, Dulles and Clemens High, and you want to go to those STEM major in the top 30 or top 40 universities, you definitely won't be able to reach to this, okay? Number 3. I know recently a lot of people get sick. If you don't feel well and you don't want to have pressure of being called by me, you can secretly tap me, teacher, I was sick. I'm sick, don't call me, okay? I totally understand. Now let's see here, Haley, let's draw this one. This is angle P, 108. And you have lowercase q, which is upper q here, and uppercase r here, okay? And lowercase q, 54. And lowercase r, which is 66, okay? Now you want to calculate this side. And then that means what? What kind of law do you want to use? What kind of law? We don't have law of sine working, right? Law of sine, yeah. See, you have this side, but you don't know this angle, and you don't know this side. So you don't have an opposite side and angle given. So for this, we have a new law called law of cosine. Law of cosine means what? Law of cosine is this. Everybody, if you don't look at this, this is called Pythagorean theorem. Pythagorean theorem is saying, if, for example, if this angle is 90 degrees, then a squared equals to b squared plus c squared. But your angle A is not 90 degrees, so you have to add additional form. If you have lowercase a, then this is going to be b squared plus c squared minus 2 times b times c times cosine of angle A. What you have is this. That's interesting. You say, oh, then is this going to be still true for Pythagorean theorem? Yes. When A is 90 degrees, cosine 90 degrees equals 0. So this term is gone. This 3 is all true at the same time. Now we are going to use this one to solve this triangle, okay? Go ahead, Haley. Plug in. Tell me P squared equals to what?
P squared.
This is you do that guy squared plus that guy squared minus 2 times this product times this. Okay.
Okay.
Go ahead.
54 squared.
Yes.
Plus 66 squared. And then minus
2 times 2 times 54 times 66 times cosine 108 degree. Okay?
Okay.
Yeah. And after you calculate it, and then you do that square root. Okay?
Okay.
Make sense?
Yes.
Could you explain the law of cosine again?
Law of cosine. You use the Pythagorean theorem to remember this. Your a squared is b squared plus c squared if this is right angle. If it's not, you have to have the additional form. You have to do this two guys product, double, and then times cosine of this angle. Okay? Yeah. If we are doing AMC 10, AMC 12, then we want to prove this theorem. But we are not doing that competition. We are just doing school AP course. Just apply it is good enough for us. See, this formula is all the same, okay? You have the opposite side equals this two neighbor side square summation minus double of their product times their angle cosine. Okay? Yeah. For the calculation part, you use calculator, so nobody have trouble. Nobody has trouble. Next one, you have two angles. You have two angles. You have 87, 70. You just use 180 minus this 2, you get the third one. And then you have this 12. So you have sine 23 over 12 equals sine 87 over this equals sine 70 over this. So this is easy. Given two angles, one opposite side, log sine, you have everything. Now, number 5. How do we do this one? Valeria, let's try number 5. This is 20. Which is uppercase M. And here is 12. Here is 9. And this is K. And this is L. Okay? What do you think? How do you solve this angle K? What can we do?
You use the law of cosine?
Law of cosine, very good. So try this side. Square will be?
So 144.
Yes. So we do 12 square equals to who?
Equals 81 plus 400.
We do 9 square plus 20 square minus who?
Minus 2 times 9 times 20.
Times?
Times cosine K.
Yes. Okay, so we have this. When we do this in the calculator, we want to know that whole thing. This whole thing is this minus this. Okay, so when you have this expression, I need all the students here being able to write down this cosine K expression in one step so that you can type in this directly into your calculator. You want to be able to write down this. When you have this, I need you being able to write down to this step immediately, okay? This is that guy subtract, yeah? So you want to get that term means this guy minus this term. and divide by this coefficient. And then you will do this here. Oh, I have typo. You minus 12 squared and divided by 2 times 9 times 20. And so you got this. And then you have this big parenthesis. And then you put this cosine inverse at the beginning. And you got this. Are you able to write down this just one step in your calculator? Do this fast, okay? So you have angle K equals to 20.6 degree. Now, if your teacher asks you 3 digits, then you do 20.592 degree. Make sure, check it. If you put it in reading, you have something looks weird. You choose the correct unit for you. Now, next one. The angle D is an obtuse angle. You don't worry about the scenario. One triangle can only have one obtuse angle, so you don't worry about scenario at all. Number 7, find the triangle area. So here is a quick summary of the triangle area. In elementary school, the triangle area is triangle area is in elementary school is 1/2 the base times the height. That's elementary school. Easiest wording. Now we have the trigonometry. We can do any two sides product times the angle between them, the sine value, and divide by 2. So you do AB sine C divided by 2 equals to BC sine A divided by 2 equals to AC sine B divided by 2. Okay? You can use this. And this one here, simple. 25 by 32 times sine of 43 divided by 2. Very easy. So this is the second formula. Third formula is called a Heron's formula. You do ABC, you plus them together, you divide by 2, you define this as a small s. And then you do the square root of s times this s minus a, s minus b, and s minus c. This is called a Heron's formula. 1, 2, 3 are all correct. Now choose the one which is easy for you to use. Now look at number 8. Look at this. Look at this. If you use the Heron's formula, it's very fast. If you use law of cosine to find the angle, and then use that formula to calculate, both ways should give you the same answer. Go ahead, my students. Try this method. Try both methods. I want to see if we have students can use Heron's formula and use law of cosine to find the angle, and then use the two-side product times their angle between sine value to find out the triangle area. And then show me your work using law of cosine, using Heron's formula. Try it on your paper. But if you say, I want to do with you, you can unmute yourself now. Good job, Ethan, too. Find the angle and then use the area formula. Do one more step to get the area of the triangle. And also compare with the Henry's formula, please. Oh, good job, Ethan. Nice work. Nice work. Very good. Nice work, Ethan one. Nice. Super good. You find two different methods and you get the correct answer for both ways. Okay, let's try this. We have students send me the answer. I'm going to show you all the steps, okay? Even though I already write down this, but I would like to do this work again to let you clearly see what we did for this question, okay? Now, first, let me still call student. Shlok, let's try here. Let's use the Henry's formula first, okay? So let's figure out S. Yeah, let's do the S. S is going to be that all three numbers plus together, right?
Yeah.
So we do J plus K plus M, okay? Which is 1/2. We do 23 plus 27 plus 18. So this is how much?
60.
50, right?
Oh yeah, 50.
50 plus 18 becomes
68.
68 over 2.
34.
34, very good. And then the area is going to be do a big square root. And then we do 34 times 34 minus 18. 34 minus 23. And 34 minus 27. Okay?
Okay.
You have this. And then you do the formula using calculator. You can have this. Okay? So we leave this expression. Now let's figure out using the law of cosine. We can do this J here is 18. We mark here, this is 18, and M equals to 27, and the K is 23 over here. Now we can use the law of cosine, okay? Let's do it. So I'm going to make 18 squared equals
324.
18 squared equals to that guy squared plus that guy squared, right?
Oh yeah.
Which is 27 squared plus 23 squared. But it's not a right triangle. So we have to minus who? Minus 2 times 27 times 23, right?
Yeah.
Times cosine of J. Okay? Yeah. And then we use cosine J equals, we will have that square minus
square,
that. Hey, hold on. this cosine j equals to that square minus that square, okay?
Yeah.
We have this minus 18 squared divided by 2 times 27 times 23. Okay? And then we can use the calculator. So if you do this, so over here, I'm going to just do this. We do 27 squared plus 23 squared minus 18 squared over 2 times 27 times 23. So we get this angle J. Now we use that thing and we do a cosine inverse. We find the angle J, which is 41.235 degree. Okay? Some people say, hey, why don't you do your 180 minus that? No. All students take class, cosine in quadrant 2 is negative. So this can only be one angle. Okay? Make sense? For the formula here. Not like sine. If you have sine in this, you might have this, you might have 180 minus this. You can have this angle, you can have the supplementary angle. For cosine, no supplementary angle. Cosine in quadrant 2 is negative. You couldn't do 180 minus that. That's not true. You only have one solution. If this is negative, this will be greater than 90. If this is positive, this is less than 90. It's an acute angle. Okay? And then we do the next formula, which is 1/2 this product this times sine of this. Okay?
Yeah.
1/2 times
27 times 20 times 41. Yeah.
So you have 0.5 times 27 times 23 times sine of 41.235. Ta-da! You have the area, which is 204.666. Okay? Now, we will do the formula, we will do the calculator for this one also to check if our calculation is correct. Square root 4 times 34 minus 18 is 16, right? Okay. And then 34 minus 23 is 11 times 34 minus 27, which is 7. Do we have same answer? Yes.
Yeah.
We even make the last 3 digits even the same. So this is 204.666. Okay? Yeah. And don't forget to put your area on unit, which is, they didn't give the unit. Okay, never mind. That's it. Okay? Now, all of this, if you give your 3 side without telling you any angle, immediately you will use a law of cosine. If they ask you solve the triangle means solve every angle, then you do law of sine again to get all the angles. That's what's going on. Any question?
So will the smallest side correspond to the smallest angle?
Yes. Yes.
Okay.
When you do this here, the smallest side, so the J is going to be the smallest angle. If you don't believe so, if you use law of cosine to find out here, if you use another law of cosine to find out here, you can compare, and you will be sure that this guy is the smallest, and this 27 corresponding to the greatest. All your previous geometry triangle inequality rule is still going to be applied here. It is still true. Any other question? No more question? Okay. So next one. Please mute yourself unless I call you to do question with me together. I put all my work here. Let's see this one. A parallelogram here. This is a parallelogram. And some people say, when you draw it, I'm able to do it, but my problem is, how do I draw it? You have to practice. This translation steps needs to be drilled by yourself. You have to read and start to draw. So what does this number 14 means? So we are going to draw this from the beginning. Siyuan, let's do this one together. So I have a parallelogram.
Okay. Yes.
I have a parallelogram. No, I didn't draw beautiful enough. I'm going to draw this, okay? And then let's see here. The angle is 35 degrees and 10 minutes here. The conversion is this guy. When you do the calculator, you have to conversion it to degree. So that means 35 degrees plus 10 over 60 degrees. Okay? Yeah. And then you draw two adjacent sides of this angle. One is 3, one is 8. So you draw this is 3. Is there a baby?
Yeah,
so this is 3. This is 8. Okay? And then you want to look for the shortest diagonal. So you want to look for this shortest diagonal. This is called the long diagonal, and this is the short diagonal. So you want to calculate this short diagonal. Then you will use the law of cosine. Okay? Yeah. So you will use the law of cosine. This is the short one. This is the longer one. So the short one is going to use the law of cosine. You do 3 squared plus a squared minus this product double and times cosine. But you have to convert this into that for you to use calculator. And you do the square root, you have the short one. If they ask you the longer one, what do? You do here. The longer one is also easy. The longer one means you do this. This is 3. And this angle is going to be supplementary to this one. Okay? Cosine of two angles, if they are supplementary. Cosine 180 degree minus theta equals to negative cosine theta. So if I ask you to solve the longer one, you will do minus cosine 180 minus this, which is plus, cosine. Angles, complementary angle is not supplementary angle. It's going to be negative of the cosine original angle. So the longer diagonal is going to be copy down here, 3 squared plus x squared. Rather than minus, you do a plus because you will going to do negative of this and cosine 180 minus this angle, which means minus minus, which is plus. So you will use this one to calculate the longest diagonal. It will ask this. Everybody pay attention. The thing you are learning right here with the law of cosine is going to be applied in your vector part. Yeah, all of the students in PreCal, you will learn vector. And in your AP physics, you will use vector also, not just 2D, you will also have 3D vectors. Okay, you will have 3D vectors. Yeah, you can mute yourself, thank you. Now, this worksheet has summarized all the questions for law of sine and law of cosine and triangle area calculation and the diagonals for parallelogram or even a rhombus. Do we have any students say I still have trouble? I'm not quite sure for specific question. I show you the first page one more time. If there isn't any question, you not feel sure, you unmute yourself. I definitely go through with you. Do we have any students say I still have trouble? You can text me privately also. Yeah, I told you guys that this year I have a student get accepted by Wharton Business School UPenn. You know, this is the top one Harvard Business School. That girl, from the first time I taught her, when she has any question, she asks me immediately. She doesn't allow any unanswered question to pass. She asks a question. If you don't understand, you ask me for help. Then your question will be cleared. No question? Then we will move on to parametric, okay? For the parametric, let's do some hard things first, and then we'll do the easy thing, okay? For that part here, if you want to survive for this, you have to remember every trigonometry formulas that I taught you. Who want to do this number 14 with me? Let's do some challenge question. Who want to do number 14 with me? Nobody? Clear? Let's try this.
Okay, let me just put it in my good notes.
Look, when we see this, you know, the decimal is really powerful. This is a parametric, so what do? We do a negative sine t, and then we do a square over here, and then we do a comma 1 minus sine t times cosine t, and then we can add a slider. Okay, and you may say, oh, we didn't see anything. Oh, it's because it's not going to show correct. It has to be reading first. Oh, hold on. Wait a moment. Let's do this one here. Hold on. Let's change this one here. We want to figure out this one in the, this is a parametric. So the t is not in x, not in y, but an independent variable. So your x change based on t. Your y also change based on t. So you have x equals this, and y equals to this. Now, we want to get rid of t.
Mean?
A parametric. So parametric is like this. You have a third variables. Previously, your y is f of x. But now, you don't know this function. You don't know the relationship between x and y. But you call your x is a u of t, and your y is a v of t. They are both not depending on the other, but they are depending on a third variables. And you want to change this one back to the x, y coordinates. So you want to get rid of t. That's the thing we want to do, okay? We want to cancel the t, but how do we cancel the t? For example, this one, it's easy to cancel. X is 3t plus 1. Y is 2t plus 1. So 3t equals x minus 1. And 2t equals to y plus 1. Okay? Then your t is x minus 1 over 3. Then t is y plus 1 over 2. The t and t cancel. So you get that. This gives you the relationship between y and x, which is a simple linear function. That's easy. These t are easily to be cancelled, but not always this can be cancelled easily. For example, this one is a challenge one. Right? How do we cancel them? Let's go on, try this. First, you have a sine square t equals to negative x. Yes?
Yes.
Okay. And then we know we can get the cosine square t. Yeah, we can get the cosine square t. Yes? Cosine square t is 1 minus sine square t. Yes? So far, so good? That is who? X, right?
Oh, yes.
Yes.
Yeah.
So this is 1 plus x. So far, so good?
Yes.
Okay. And then we get here. So we can move around. This means sine t cosine t is 1 minus 1. So far, so good? And then we can square both sides.
For both sides?
We do the square for both sides. That makes sense?
Yes.
We do the square. We do the square. So you give the square to here, give the square to here, and you have this. Okay? So far, so good?
1 equals to 1 minus y squared?
Not 1. This is not 1. This is not plus. This is product. If this is plus, this is 1. This is the product.
Oh.
So you have that. This can be replaced by that. Okay? So you have negative x times 1 plus x equals to 1 minus y parentheses square. Okay? Makes sense?
Yeah.
Right. And then we are going to move around. So we are going to do this. This is negative x minus x squared, right? Correct?
Yeah.
And we move everything to the right. Okay? So we have 0 equals to x squared plus x. We do 1 minus y squared, which is the same as y minus 1 squared. Okay? Negative 2 squared equals to 2 squared. So you can flip. Okay? So far, so good?
Yes.
So you have x squared. You have x squared plus 2 times x times 1/2. Yes? Plus 1/2 squared. We are doing the completions for the square. Yes? Equals.
Yes.
Equals to 1/2 square. Does this make sense?
Yes.
Right? So this is this. This is this. This is this. So this is the thing to balance. Okay? So that 3 terms becomes to this. Make sense now?
Is that a circle?
Yes, that's a circle. Oh, even though this thing looks like weird, but this is a circle. This is a circle at center of who?
Negative 1/2 1.
Negative 1/2,
And then
comma 1
radius.
equals to 1/2.
Oh, squared. Yes.
Yes. Now let me check what's going on over here. So this is what? This is x squared plus x plus parenthesis y minus 1 and parenthesis square equals to 0. Yes. Now, let's go back to draw this thing. So for the parametric, you do the parentheses inside the, and then you do negative of sine t. And then you do this sine t parentheses square. And you do comma. And you do 1 minus sine t times cosine of t. Yes, now it's showing. And you can make your t like this. Okay, did you see? This is exactly going on. Okay, yeah. Now you see they are the same. You say why it becomes a ellipse? No, it's because the x-y ratio are different. Yeah, it's because the x and y ratio are different. Yeah, now you change to the same ratio, it's equal. Okay, yeah. Did you see? Your x-y coordinates equation and your parametric format, when you input, if you do the conversion correct, it should be exactly the same figure. If one doesn't overlap with the other, something wrong in your conversion. For example, if I do this, if I change this center to be a 0.5, no, that means our conversion is wrong. When we do the completion square, we messed up somewhere. If you did correct, it should be exactly the same. And you might say, your XY coordinates sounds so simple. Why you bother to do that way? Well, it's going to, for the purpose to learn more advanced level. This in here is still not advanced. Now, during Algebra 2, most kids here learned Algebra 2 AAC with me before. So you might remember the Connie sessions. Yeah? I know some people don't like Connie sessions. For pre-calculus, everybody from Dulles Academy, you want to pay attention. Your school will definitely give really hard question with conics and parametric with the polar system. It's very scary. We want to do this part very hard. So for that, look, something interesting will happen here. And let's call Catherine. This and this. We know the trigonometry identity is this, correct?
Yes.
Okay. We are going to use that identity for here. Cosine t equals x over 4, right?
Yes.
Sine t equals
Y over 2.
And then that get squared plus that get squared. Who is that? X squared over 4 squared, which is 16, plus y squared over 2 squared, which is 4, equals to 1. Who is this?
Ellipse.
This is ellipse. This is a beautiful ellipse. So if you do that, if you do this in here, we do 4 cosine t, comma, and 2 sine t. And you say, hey, well, the thing you show is it's not, it's just a part of the curve. Well, because you didn't make your t bigger enough. If you make your t bigger enough, you will have the beautiful ellipse. Okay, yeah, that's going to be a beautiful ellipse. So if you say, so what does that mean? So if x squared over a squared, you plus a y squared over a b squared, and you make it equals to 1. You say, oh, this one you didn't show anything. The equation you write down there is not showing anything. Well, because your a is a variable, your b is a variable, then you have to add in this slider to be able to show. When a and b is equal, it's x squared plus y squared equals 1. It's centered at 0, 0 with a radius of 1. But if you make your a, see, you make your a bigger. That's an ellipse. If you make your b bigger, then you have the vertical direction of the ellipse. And you can also shift this ellipse center. It doesn't have to be in the center 0, 0. It can be anywhere in the xy coordinates. So what's the good thing of using this? What's the good thing of using this? That's the thing when Dulles Academy has the most difficult parametric force problem. You will use this to show the person on the first view. And you can use the parametric format to show the position of the ball. Okay? Yeah. So seriously, Dulles kids, when you come to this part, this is the hardest parametric equation words problem you will see. And you want to use this, if you are able to type in this by yourself correctly, not just copy down my work, but do by yourself, you truly understand this part. You don't have trouble for any of this part of question. If you can do this by yourself in the decimal correct, then you can easily do it in your TI-inspired graphing calculator. Understand this first, and guarantee you will understand this part very well. Now, this center is 0, 0, easy. What about the center not at 0, 0? Eason 2. Let's convert this to the xy coordinates equation, please. Go ahead. What do you do?
Do x minus 3 equal to...
I'm going to divide by 2 directly.
Okay. Equals to cosine t and y plus 1 is equal to sine t.
Go.
And x minus 3 squared over 4 plus y plus 1 squared over 1 is equal to 1.
Yes. Who is this?
An ellipse.
Center at?
3, negative 1.
Yes. And the major direction, see here, you have an ellipse like that, right? Right. So did I say when you future and you want to get an internship in this software company, and then you have to know this formula. Otherwise, how do you write down the code there? You don't know that formula, you can get the correct code? Not possible. And how much is this? based on here?
4.
How much?
Two.
No, that's
Two.
2. Yes. This is 2 squared. So this is 2. This is another 2, right?
Yeah.
So this is 2. From here to here is 2. From here to here is 2. This total major x length is 2a, which is 4. Now how much is this?
1.
This is also 1. Okay?
Mm-hmm.
Yeah. That makes sense?
Yeah.
Well, we just write down this suppose center as 0, 0. And then you have 3, negative 1. So you have to shift every point horizontally and vertically. Okay?
Mm-hmm.
Okay. Does this make sense now?
Yeah.
Now, Eason 1, let's try 17. This time it's no longer an ellipse. But what are they? Who is this guy? What do you do?
Tangent is 1 and 2.
So the formula you are applying here is by secant squared t equals to who? Tangent squared t plus 1. Okay? Make sense? Okay. And then you have, this is x squared, right? Equals tangent squared t, which is y over 2. So y over 2 squared plus 1. Okay? Make sense? So you have x squared over 1 plus, not plus, minus y squared over 4 equals to 1. And who is this?
The hypotenuse.
The hypotenuse. The hypotenuse, you think this is a horizontal direction or vertical direction?
Horizontal.
Very good. Some people say 4 is bigger than 1, so this is vertical. No, not at all. For the ellipse, who is greater decide the major direction. For the hyperbola, A and B value doesn't decide which one is the major. Who is a positive term is a major. Who is a negative term is a minor. When I teach you the hypotenuse, the hyperbola asymptote, do we have any student know how to calculate that guy's asymptote? Don't say it. If you know it, text me. Do we have any people know how to get this hyperbola asymptote equation? What are the equation for this? How do we get this guy's asymptote? Who is this guy's asymptote? Asymptote equation is what? Look, you have this. You have this one. What will happen if you have a center shift? The best, easiest way to find the asymptote is by making this 1 to be 0. You immediately get your asymptote. Look, this question, you have no shift. I'm going to search one which you have to do the shift. Yes, for 31, you have the shift. So what do you do here? Daniel, let's convert this to the XY coordinates. What do you do?
Tan t is equal to x minus 6 over 4 and secant t is equal to y minus 2 over 6.
And then what do you do?
The square of y minus 2 over 6 is equal to 1 plus the square of x minus 6 over 4.
So you do this, okay? Correct?
Yes.
Equals to 1. Look, I'm going to let you guys see. If I change this to be 0, that's going to be the asymptote. Do you believe? Oh, you have this. This because that's a positive term. Not because this is 6 greater than 4. No, it's because this one is positive term. Even you make this guy to be 8. This is still a vertical one, okay? Now, everybody, you watch out this carefully. It's like I'm doing a magic, okay? I copy and paste, and I change this color to be green. Okay, look, you say, oh, you are just duplicated this. Yes, now I'm going to change this to be 0. Boom, that's it. Is that a magic? That's a magic. This is the fastest way to get the asymptote for the hyperbola. You don't need to remember any formula because sometimes it's horizontal, sometimes it's vertical. So you could got confused by your A and B, who is on the top, who is on bottom. And when you have the center not 0, 0, you will have those shift. You have trouble to get the equation for the asymptote. Don't remember the formula. Just make this equal 0. You have your asymptote immediately. If I ask you, what's the asymptote? And what's the asymptote equation? You will do this copy and paste. And you solve this equals to 0. But the problem is, if your school teacher don't understand this, will think you as wrong. So you can do this step, and you can do y minus 2 over 6 equals to plus minus xo minus 6 over 4. That's the asymptote equation. Immediately, I guarantee you'll get a perfect answer. You make this equal 0, so this equal. And that means this equals plus minus this. It's identical. It is always identical. Okay? Yeah. I see. Really? Are you sure? Yes, I'm sure. And you say, oh, did you see this from somewhere? No, this is my own formula. I don't see this from anywhere. I did this by myself. A lot of things that I teach you guys, some of them or most of them is my own creation. So you have this blue one, and you can duplicate. And then you can fix this by putting a minus in front. That's it. Now you believe that this and that are identical. Do you? They are identical. Okay. So if you have quiz about find the hyperbola equation and find out the asymptote, if you're struggling with, remember the long formula, forget about it. Do this and one step. But if your teacher don't understand this, don't show her this work, okay? And she may say, oh, this is 1, you change this to 0, that's crazy. Then don't show her. Just show this correct last answer. Some people ask you, how do you get this? You say, I just have this sense. I got this immediately correct. Now, if you come to here, parametric equation, when you have something, you throw it to a different angle, not just vertically up, but to a certain angle. This is algebra 1. And you might wonder, hey, how do you get 16? What does 16? If you are using feet as a unit, you have 16 because the gravity is 9.8 meter per second square. 1 meter is about 3.28 feet. If you do this two product and divide it by 2, that's going to give you a 16. Now, that's how you get this 16. So this 16 is because of gravity. So you need to know this basic formula, okay? You threw something upward, and your displacement from the ground is by using negative 16t squared plus v0t. This is your vertical initial velocity plus the horizontal height. Okay, if you threw a ball from 10 feet, then you have to plus 10 feet relative to the ground, the sea level. Now look at this. This is what? This is you threw this, okay, with a velocity. So the iron was thrown with that velocity, 35 degrees. And the velocity is 135 feet per second. And they ask you that this guy, there is a 100 feet palm tree. So the palm tree is here. Yeah, sorry for my bad drawing. I don't draw very well. That's why when you were little, when you were young, you want to learn different skills. You don't learn it at an early age. It's really hard for you when you want to learn it, okay? When you are old. Now, this ball is flying. It's flying like that. And they ask you, can this ball clear, okay? So this is something like that. So what do you have to calculate? The flying horizontal distance is 100 feet. This is 100 feet from here to here. And this is a tree standing at this position, and this tree is 70 feet. And your ball is flying horizontally. Your ball is flying with a velocity of 135 feet per second times cosine of 35. So this times cosine of this.
This is physics.
Yeah, this is physics, of course. So you have this horizontal. So you have this horizontal distance, which is that guy times cosine of that. You fly in this direction. And vertically, you have this times sine of that as the initial velocity. But because of the gravity, so your vertical direction is this. You are not throwing from a height, so you put 0 here. So you make this guy equals to 100. You make it equals to 100 feet. And you can solve the amount of times that this ball is flying. And then you solve this t based on this, because horizontally you are using this velocity to fly horizontally. You can ignore the friction of the air. Now, even though there is friction, but right now we don't do so that difficult stuff. We just ignore it, horizontally flying. You use 100 divided by that, you solve your time of flying time. And you plug in your flying time to solve the ball's height. Okay, you find your flying time, you use this t to plug in. If this y position is greater than 70, you call this guy cleared. If you are lower than this, so this ball will be blocked. That's how you solve this kind of question. Okay. Does anybody say, I don't know what you're talking about? You unmute yourself. I try to explain to you. So this is not hard enough because this one just have a ball flying with a certain angle. You don't have the Ferris wheel involved yet. So we want to make sure you can solve this kind of question. And then later, we will solve the ball, throw into the Ferris wheel to see the person on the Ferris wheel can catch or not. Okay. That's for today's class. If you say, I really need your help, you stay with me. Okay. If you have a question, you need my help, you stay with me. If you don't have a question, you can leave. And I'll see you next week. I just quickly go to the restroom and you can wait me for 2 minutes, okay?